In the previous video, we had a look at adding tools to our agent, like the web search tool. This allowed the agent to retrieve real-time information from the web. But another way to add additional context to these agents is to provide a custom knowledge base. This means you can upload things like Word documents or PDF files, and the agent will be able to answer questions from your knowledge base. This usually involves setting up a vector database with a service like Pinecone, and then connecting your agent to that vector database. But the OpenAI Responses API makes the setup extremely simple. So let's have a look at this. To start with, I've created this very simple boilerplate for interacting with the Responses API. And if we run this file in the terminal, we get this response back from the agent. So now that everything is working, let's have a look at assigning a custom knowledge base to this agent. The first thing we need to do is to create this custom knowledge base or vector database. To create a vector database, log into platform.openai.com. Then click on Storage. Then select Vector Stores and then click on Create to create a new vector database. Let's simply call this my custom knowledge base, like so. Now we can simply add any files to this database by clicking on Add Files, then click on Upload, and then upload any file, like a Word document or a PDF file or a text document, to your knowledge base. I uploaded this FAQ document for a fictitious restaurant called the Oak and Barrel. So what we could do is ask questions about the restaurant, like the phone number, or maybe questions about the menu, like what the current specials are. So here we can see that this week we're offering 50% off all steaks and a happy hour between 4 and 6 p.m. So you can upload as many files as you want and then finally click on Attach. Great, we now have our vector store set up and we uploaded some data into our vector store. Now let's give our agent access to this vector store. Back in our code, let's create a new variable called tools, and this is equal to a list. This is similar to how we assigned the web search tool in the previous video. So we have to pass in a dictionary, and this dictionary takes in a few keys, like the type, which is equal to file_search. And by the way, you can find the name of these tools from the documentation. So within the built-in tools section, you simply go to file search, and in the section, you can see the tool called file search over here. Then we also have to provide another key called vector_store_IDs. And here we can provide a list of vector store IDs. Back in the OpenAI dashboard, we can simply copy the key, like so, and add it to our code. The nice thing about this solution is that you can attach more than one vector store as well. So you can simply add a comma and add another ID. We'll just keep to one for now. Optionally, we can also specify another key called max_num_results. And we could set this to something like 2. This will simply tell the vector database how many related documents to return back to our agent. So what the vector store effectively did was take our Word document and split it into smaller chunks. This is important for keeping the token usage low. So what we can do is tell the vector store how many entries or how many documents to return. And if I find that the model needs more context, I can simply increase this to any other value. Right, let's pass these tools to our agent. So just below input, let's add another property called tools, which is equal to our tools list. Let's try this. I'm going to change the user's message to what are the current specials. And now let's run this script. So in the terminal, let's run this. I'm just going to expand this. And our agent is saying that the current specials at the Oak and Barrel are 50% off steaks and happy hour between 4 and 6 p.m. This is great. We can add additional files to our knowledge base or remove files at any time. Now, if you have multiple files or multiple vector stores attached to the agent, you might want to know where this information actually came from. Thankfully, the agent does return all the citations as well. So let's do the following. I'm going to change this to response.model_dump_JSON, and I'll set indent to something like 4. This will just make this output a little bit easier to read. So let's run the script again. Let's have a look at the output though. This is a list of values. The first entry tells us that the file search tool was called and it passed these queries to the database. Then for the second entry, we get this dictionary with a type of message. This is the entry that we're interested in. Within this object, we have this content property, which is also a list, and within content, we have this dictionary containing the annotations. And this will tell us what the file ID was, as well as the file name. And secondly, we also get this text property, which contains the response from the LLM. Now you will notice this doesn't give us the actual search results, and I will show you how to get those as well. But sometimes you simply want to show the annotations or the citations to the user. So let's have a look at how we can get those results. First, I'm just going to print something like agent answer, and this will be response.output text, like so. And secondly, we want to print these annotations. So let's print, I'm just going to say annotations, and below this we can now output all of these annotations. So this could simply look something like this. For output item in response.output, so we're simply looping through this output property, which is a list, and what we want to do is look for any dictionary that contains the type of message. So let's loop through output, then let's say that if output item dot type is equal to message, then let's have a look at this object again. So if the type is message, so it's this object over here, then we want to loop through the content property, which is also a list, and we then want to grab the dictionary that contains this annotations property. So let's continue with this. So let's say for content item in output item dot content, then we can simply say that if the content item dot type is equal to output text, so it's effectively this type over here, which will give us the annotations as well. So if the type is output text, then we can loop over the annotations. So let's say for annotation in content item dot annotations, and then we can say if annotation dot type is equal to file citation. So all we're doing is we're saying that if this annotation is of type file citation, then we just want to print out the file name. This is simply catering for the event that we might have different annotation types. So for file citations, we'll just say print, and let's just add an F string, and let's say something like citation from file, and let's pass in annotation dot file name. All right, that should be it. Let's actually run this in the terminal, and we get our answer back. And from the citations, we also see that this answer came from this file. Now, what if we wanted to also see the results that were returned from the database itself? So the actual chunks of text that were used. Thankfully, the Responses API also returns that information. Let's go back to our create method, and let's pass in a property called include. And this is a list of values, and let's include file underscore search underscore call dot results. Now let's have a look at this output object again. So let's run the script, and let's have a look at what we got back. All right, so we get this object back, and looking at the output, in the first dictionary call, we still get our queries, but because we asked it to also return the results, we now also get this results property, which contains a list of all the results from the database. So this also gives us the file name, the relevancy score, along with the text that were returned from the database. And because we said we wanted 2 documents to be returned, we do get this first one, and scrolling down, we also get this second document as well. Now retrieving this in our code is actually really straightforward. We're already looping through the output, so let's simply add our logic to this loop over here, and let's say if output item dot type is equal to file underscore search underscore call. So effectively it's this very first object that we get back, this one over here, and from this we simply want to grab this results list. So if the type equals file search call, then let's print something like search results, and then let's loop over those results. So we can say for I and result in enumerate, and we can do output item dot results. And this is simply so that we can also include a counter in this. So then let's say print, I'll simply add an F string, result, and we can show the number like result 1. And also we want to start this iteration from number 1. Then let's also print another F string called file name, and this will be result.filename. Then let's also print another F string, and here we'll also return the relevancy score, which we can get from result.score. And finally, let's also show the text snippet. So we'll just pass in another F string, and let's say text and snippet, and this will be equal to result.text. And let's say we only want to grab the first 150 characters, because you might have noticed that these results can be quite long. So we'll just grab a snippet from it, and we'll just add dot dot dot. Or if the text is less than 150 characters, then we can simply do if the length of result.text is greater than 150, else we'll simply return an F string with the text snippet, and we'll simply pass in result.text as is. Cool. So this should now give us all these search results, and I think we also have to move this annotations print, as it no longer makes sense up there, and it's simply added just above this annotations loop over here. Right, that should be all we need. Let's run this again, and looking at the result, we get the correct answer back from the agent. We also get our search results, so for the first result, we get the file name, the score, and the text snippet. Then we also get the second result, which gives us the file name, the score, and the text snippet as well. And finally, we get our annotations. Right, our agent is definitely starting to get a lot of superpowers. It can go online, it can answer questions from our own knowledge base, but what if we wanted to create our very own custom tools? I'll show you how to do that in the next video.